say I've got an adenine here, which is a bigger block. We'll put an A in there. I've got cytosine here, which is a smaller block. I've got thymine here, which is a smaller block. And actually, this shouldn't be there. This should be over here, let's say. And then we'll put a guanine over here, which is a bigger block. Okay, we've got all four. Now, on the other side of this, because we know that this is only half of a DNA strand, right? If I were to have a purine, and we know that our purines are A and G, and our pyrimidines are T and C, right? If I were to have a large purine bonding to a large purine here, and then I'm going to have my sugar, phosphate, stuff going on again over here. Now, if I have these two large ones, and let's say in the next set of nucleotides, I have a small one bound here, look at all the unevenness that creates. And let's say a larger one is bound here, and another large one is bound there. It makes a really uneven molecule. You cannot have that. That is why we always have a larger G bound to a smaller C, or we always have a larger A bound to a smaller T. Okay, so if we put C here and we put T here, this makes sure that our DNA strand is going to be even the whole way through. That is super important. So Chargaff's rule talks about being able to determine the number of nucleotides in a sequence based on knowing at least, or knowing the amount, let's say, of at least one of the four nucleotides. Okay? So Chargaff's rule states that G's, the number of G's, are always going to be equal to the number of C's, right? Because they bond together. The number of A's are always going to be equal to the number of T's. So if we look at this, all right, if we want to do a mathematical problem here, if I were to tell you that you had something like, I don't know, you had a total of 450 nucleotides. So that's a segment of DNA that's got 450 nucleotides in it. Okay, and I told you that you had, let's say, 105 adenines. How many guanines, cytosines, and thymines would you have if you knew that you had 105 adenines and your total of nucleotides was 450? What would you do? Well, you can't divide by 2. They're not evenly divided. That's a good guess, though.
So you multiply the 105 by 2 because it's the same amount in the T, and then you divide the answer by 2.
Okay, so here's what we know. According to Chargaff's rule, if I've got my number of adenines in my set of nucleotides, then I also know my number of thymines, because A is equal to T, right? So this is going to imply that I also have 105 thymines. Can I get a total of these guys? 210. If I add them or I multiply this by 2, I get 210. What is my total number of nucleotides? So what can I do here? 450 nucleotides minus 210 gives us 240 nucleotides remaining. What else do I know about my C's and my G's? They have to be equal in number. So how can I figure out how many C's and G's I've got? Oh boy, look at that. Divide that by 2, and that's going to give us 120 C's, 120 G's. We already know that we have 105 A's and 105 T's. That is Chargaff's rule. It is not a complicated math computation. You just have to know that the number of A's and T's equal one another and the number of C's and G's equal one another.